Understanding. Chalo. Let's resume with our revision lectures. Um, Today we are starting with central force, and we will also take the flipping case.
Excuse me, sir.
And there have been questions that I have received from other students too. So as soon as I will find time, I'm going in the basically in the ascending order only on the basis of the time that they have sent to me. So, but yes, I will respond to that as soon as possible. Don't worry. Okay? But you will get the detailed solution of it only. Don't worry about it. Okay? Sure. Let's resume. Just a second. Do you guys have any questions in classical mechanics so far? The things that we have discussed, like velocity, acceleration, Newton's law, pseudo force, friction, variable mass, all of it. Okay, then let's
जो
start.
साइक्लिक मोशन का जो क्वेश्चन पूछा था एंगुलर मोमेंटम वाला, ये सर 2014 का क्वेश्चन है।
Okay.
आपने बोला था कि एंगुलर मोमेंटम का डायरेक्शन कांस्टेंट रहेगा,
एंगुलर मोमेंटम
का डायरेक्शन कांस्टेंट रहेगा।
हाँ, yes, absolutely.
बट यहाँ पे ऑप्शन पे चेंज हो रहा है, डिपेंड ऑन दिया है।
No, फिर वो मुझे क्वेश्चन भरना पड़ेगा. You have to tell me the question. It depends then.
ओके सर, आई इन मैसेज आई कैन डू।
ओके, हाँ, मैसेज
सर।
ओके, ठीक है. So just a second. Why is this not working properly? Just a minute. Because it has to remain as far as position vector is constant now. I mean, so r cross p is constant. It has to remain constant. There is no option. Just a second.
तो ठीक है सर, यहाँ पे पोजीशन चेंज हो रहा है, 0 पे और ओरिजिन पे था और एक बार 100 पे।
तो हाँ, तो फिर then L will also change ना यार. Okay,
थैंक यू सर।
no problem. चलो, let's proceed. Central force. Okay. Actually, I want to take a few questions only on this direction, but let's recall a few things related to central force. First of all, the definition, people, that a central force is basically when force is a function of position vector. Okay, and you will have some constant. It's not necessary that r has to be in the numerator. Like for example, kr square is a possibility, k upon r square is a possibility. It could be anything. It just needs to be a function of position. Kr cube, 4kr raised to 4, sin r, log r, anything, we don't care. It has to be a function of position. That's the whole idea. Okay, so there will be magnitude and there will be direction. Now this direction is always along the line joining the two centers if you are talking about two body system, and usually we have converted a two body into one body. That is also we have learned during the class how to convert two body to one body, basically by finding reduced mass, if you remember. And then plus or minus, this is really important. Listen, in exam, suppose I may give you or they may give you force is given by 4r cube. Don't substitute 4r cube directly. Read, if it's an attractive force, you have to write minus 4r cube. And if it's a repulsive force, then you have to write plus 4r cube. So many a times they may give you magnitude, but separately they may have written that it's an attractive force or it's a repulsive force. So accordingly, you will have to take care of the English people. So plus or minus, plus will be used when you have a repulsive force, okay, and minus will be used when you have an attractive force. Okay, this was one important property. Another was, if you remember, central force is a planar motion. That is what we had established. When you say planar motion, it means what? That r vector and v vector were in same plane, people. We had derived this in the class. Were in same plane, always. We are not saying they have same direction. We are saying they are in same plane. So for example, if this is a plane, then if this is r vector, v vector can have an angle with respect to r vector. We don't care what is the angle. 25 degree, 30 degree, 40 degree, 50 degree, 80 degree, whatever could be the angle between r and v. But they will be in same plane at the end. It won't be like r is like this and v is not going to go in some other plane, people. This rectangle will be fixed. And because r and v will be in same plane, what happens when you take the cross product? R, when you, pardon?
No, sir, nothing.
So because r and v are in same plane, when you talk about angular momentum, which is r cross p, okay, so this becomes r cross m into v, okay. since R and B, the plane is fixed, so the cross product of it, the perpendicular direction to the plane, that will also be fixed, and L vector will also be fixed. L vector will also have a same perpendicular direction. So the direction of L vector also remains constant. Okay, and I can write L vector will have, it will be perpendicular. It will be perpendicular to R comma V plane always. And because plane is fixed, angular momentum is also fixed, people. Because plane is fixed, angular momentum is also fixed. Now, then we had learned that the torque, which is rate of change of angular momentum with respect to zero, torque becomes zero because angular momentum is constant. Okay. And there is another way to understand that why torque becomes zero, because torque is also R cross F. Okay. And this becomes because torque, because F vector, people, F vector is actually what is F vector? F into F of R into R cap. F vector is F of R into R cap now, and R vector is R into R cap. So we know I cross I is 0, J cross J is 0, K cross K is 0. So R cross R will also be 0, torque will also be 0. This is also another way to understand that why torque is 0. Another way is angular momentum is constant, so torque will also be 0. So these are actually popular points for an MSQ. Like they can give you in a central force motion, which of the following is or are correct statements. So it's a planar motion, angular momentum is constant, aerial velocity is constant, torque is 0, then R comma V are in same plane, or anything related to that. For example, the force lies along the line joining the two centers for a two body system, or anything like that could be framed people. Okay. So that's about the fundamentals of the chapter. Proceeding ahead. Achha, I just want to add one thing before I forget. People, you have learned, for example, this is related to gravitation, but it just clicked in my head, so I'm sharing. The formula for time period for a circular orbit. Have you by hearted the formula for a time period of a circular orbit? Gravity.
4 pi square G by M T
to the power 3.
R to power 3.
Okay, yes. So it's 4 pi square into R cube upon Gm. So either you remember it like this, or you remember T is 2 pi under root of R cube upon Gm. Anything is fine. Okay. So from here, basically, you get T square is proportional to R cube. You need to by heart this formula. Important thing is, very important thing is, people, you need, like, this formula is fine, but what is the meaning of each and every term? For example, if I give you, let's say, a system at the center and somebody is revolving around it. First of all, what is capital T here? Time period of revolution. Time period of revolution. Okay, from here to here, whatever is the time taken from here to here, time period of the revolution. That's T. Okay. Next, small r, that's radius, that's understood. But what is M here?
The center, capital M, sir, the center pe.
It is mass of the object which is at the center. Mass of sun, basically, if Earth is revolving around the sun. So the point is, actually, there was a very good question. I think I have taken a screenshot of that question, which was asked in one of the IISc paper. Most of the students, use T square is proportional to R cube. Okay, it is not always correct. People, T square is proportional to R cube only if your capital M is constant. Now, only if your mass at the center is constant. You know what they had given in that question? They had given two different galaxies, Galaxy 1 and Galaxy 2. And in Galaxy 1, they had given that there is a sun at the center and there is a planet which is revolving around it. And in Galaxy 2, there is a different kind of a sun, basically a different kind of a star at the center, and some another planet is revolving around it. And they had asked what is the ratio of T1 upon T2. Students have ended up using R1 cube upon R2 cube. Like T square is proportional to R cube, that formula. But masses of the object at the centers will be different now, right? I think I have taken the screenshot of that question. Wait, I did type it, but not sure if I.
सर reduce mass होगा ना सर यहाँ पे?
No, यहाँ पर reduce mass नहीं आता है.
सर आप जो क्वेश्चन बोले यहाँ पे गैलेक्सी वाला.
नहीं, यहाँ पर आपका कैपिटल M ही आता है. T is 2 pi into under root of R cube upon G capital M. No, this is mass of the object at the center only. It has nothing to do with this mass at all. It is independent of the mass of satellite. It is like if satellite is revolving around Earth, then time period of revolution of the satellite is independent of the mass of the satellite. There is no reduced mass concept. Why?
हाँ सर, आप जो गैलेक्सी वाला क्वेश्चन बोले ना,
हाँ, उसमें भी doesn't matter. अरे it's the same thing. For example, Earth and satellite. Satellite is revolving around the Earth. So you are not using reduced mass here. T square is proportional to R cube when you write the capital M is sorry. Capital M is the mass of Earth only. So similarly, if you are talking about galaxy and if there is a planet, capital M will be mass of galaxy only. It won't be reduced mass. It will be mass of the object at the center here.
yes sir.
Okay. So wait, I will just show you that question. I think I have saved it. I did it day before yesterday, so not sure which was the question number. We'll have to find it. 15, 16, it should be 19. No. 20, no. 21. Yes. Okay. Let's take this question right now. It is one of the IIT paper question only. So there is a 4 into 10 raised to 6. Do you know what is this called? Achha, they have written solar mass. Solar mass means mass of sun, people. This is mass of sun 2 into 10 raised to 30 kg. Yeah? By heart it. Mass of sun. Okay. So there is a 4 into 10 raised to 6 solar mass black hole in the center of our galaxy. Okay. So basically, obviously, in the center of our galaxy, that is basically, they are speaking about sun right now. So we have got sun. And in our galaxy, we have got this, let's say, some planet. Let's talk about Earth, maybe, you know. We have Earth. Earth revolves around the sun. What is time period of revolution of Earth, people? 1 year. Time period of revolution of Earth, that's 1 year, which is 365 days. Or depends, do you want to write it in hours, seconds, minutes? So I'm just writing right now, it's like this. You can write it however you want. A star with much smaller mass than the black hole in an elliptical orbit around it is observed to complete a full orbit of 15.78 years. Okay, so now there is a star peak. Okay, wait. So there is a black hole in some other galaxy, yeah? And the mass of the black hole is 4 into 10 raised to 6 times solar mass. Remember, mass of sun is solar mass. Huh? Mass of sun is solar mass. Mass of black hole is 4 into 10 raised to 6 times solar mass that they have given us, 4 into 10 raised to 6. Okay. And there is some another star. There is some another star which is revolving around the black hole, people. Okay. So about this, I was speaking. People, T square is proportional to R cube. You can use this for circular motion. But when it comes to elliptical motion, R is replaced by A, and A is semi-major axis. Remember that. I have told you this in the live class also. R is replaced by A, people. A is semi-major axis for elliptical motion. Mention it very clearly. Semi-major axis. Okay, mention it please right now. R is replaced by A. What is semi-major axis? So if you have an ellipse, so this is minor axis now, and this becomes major axis. So minor axis is 2 times B, and major axis is 2 times A, people. So major axis is 2 times A. So semi-major is A. Simple. Okay. So similarly, energy formula. What is binding energy formula, total energy formula of a satellite which is revolving around the Earth, not on the surface, which is revolving around the Earth? What is the binding energy or total energy formula? Magnitude. So total energy of a satellite revolving around the Earth. For example, total energy of Earth revolving around the star. Total energy of Earth. Let's say Earth has a mass small m. What will be the formula of this Earth when it is revolving around Sun? Total energy formula.
G(m)m upon 2r.
Yes, minus total energy is negative. It's and binding energy is positive. So minus G capital M small m upon 2r, people. Now again, small r will be replaced by A, people, in elliptical motion. Mention this. So total energy for ellipse becomes minus GMM upon 2A. Mention it, please. Actually, I did not plan to teach these things, but it's okay. We are discussing this very critical stuffs. Okay. Total energy is minus GMM upon 2R, and total energy in ellipse it becomes minus GMM upon 2A. Any questions, anyone so far? Okay, I'm going to the next page. So let's discuss this question. So they have mentioned that there is a star with mass much smaller than the black hole. That's okay. In an elliptical orbit around it, is observed to complete a full orbit in 15.78 years. So this star's revolution is given to us now. It completes its orbit, people, in how many years? 15.78 years. And the semi-major axis of the star's orbit is, so they are asking you the semi-major axis of the star's orbit, A. So now you know what you are supposed to do. You know, students would have used T square is proportional to R cube, but you cannot use this. The reason is, for Earth and Sun, the mass of Sun is different, and for star and black hole, the mass of black hole is different. So T square is proportional to R cube, but upon you have capital M2, because the formula is T square is 4 pi square into R cube upon G capital M. G is constant. G is universal gravitational constant. So 4 pi square and G are always constant. Otherwise, T square is proportional to R cube upon capital M. So that's it. So time period of, let's say, the second system, or you can say the star system, upon time period of Earth, it will be what? It is proportional to R cube. So radius of Earth upon radius of star, the whole cube, and it is inversely proportional to capital M. Now capital M, when you say inversely proportional, okay, for Earth, people, for Earth, you have Sun. For Earth, you have Sun. And for star, you have black hole.
Black hole.
Have you understood this relationship, all of you? Remember, there is inverse proportion now, and hence I have written Sun here and black hole. Anybody, do you have any question in this?
Please repeat it.
Sure. So basically, okay, let's write it this way. You know, one thing at a time. Leave this. What we can do is सबसे best. Okay. So T square formula is 4 pi square into R cube upon Gm. So people, what is the time period of Earth? It will be 4 pi square into radius of Earth, like radius of orbit of Earth, not radius of Earth, radius of orbit of Earth, revolution. Okay, upon G into mass of Sun, है ना? Similarly, time period of the star that you have, it will be 4 pi square into radius of orbit of star. Okay, but they are asking you semi-major axis, so you can write A also if you want, doesn't matter, R or A. Okay, upon G into mass of star is revolving around whom, people? It is revolving around black hole. Understood? Take ratio. So if you take ratio, what do you get? Time square of Earth upon time square of star. This is equal to 4 pi square gets cancelled, G gets cancelled, radius of Earth upon radius of star, the whole cube, into mass of black hole upon mass of Sun. All good now?
Yes, sir.
Okay. Yes. So let's calculate what is time period of Earth 1. What is time period of star they have given us, which is 15.78. If you are thinking, but sir, don't you convert it? Should not be convert this into SI unit. Arey nahi na, year it gets cancelled. Year gets cancelled. If you multiply 365 dash dash dash, it gets cancelled anyway. Square. This is equals to radius of Earth, which is
6,400.
6,000.
no, not radius of Earth. It's radius of orbit of Earth. Ray. I told you that.
Okay.
It is given to us, and that is 1.5 into 10 raised to 11 meters. 1.5 into 10 raised to 11 meters. Here, distance between Earth and Sun. Pardon?
सर एम ब्लैक होल का आएगा, आपने स्टार लिख दिया, एम स्टार अपन एम सन.
ब्लैक होल ही लिखा है ना, एंड सन लिखा है
ओके सर.
है ना? क्या हुआ? कहाँ कंफ्यूज हो गए?
अरे BH दिख रहा था.
BH is black hole. हाँ. Okay.
सर ऐसा ना.
Okay, no problem. So radius of Earth, that's 1.5 into 10 raised to 11. Radius as in radius of orbit of Earth. That is given to us. Distance between Earth and Sun. Now, that's the radius of orbit of Earth. Distance between Earth and Sun. By heart, this value 1.5 into 10 raised to 11. Okay. Upon radius of orbit of star, that they are asking us. Okay, that they are asking us. Mass of black hole, that they have given us 4 into 10 raised to 6 times solar mass. And mass of Sun, that's solar mass, people. Understood? Any questions? Mass of Sun is solar mass. Okay. Solar mass is known as mass of Sun. and mass of black hole is 4 into 10 raised to 6 times solar mass. And now we can use calculator and check very quickly. So our answer is 1 upon 15.78 the whole square. This is 1.5 into 10 raised to 11 upon radius of star the whole cube. Mass of solar mass and solar mass get cancelled, and we have 4 into 10 raised to 6 here. Okay. Can you complete the calculation very quickly? Please check. Let's check the answer. Acha, by the way, what software have you been using to calculate?
आपने तो बोला था गेट कैलकुलेटर.
I hope people, all of you are using the gate calculator application. Do not use your hard calculator, the calculator that you have been using in your college life. Please use that application, the software only. Practice on that. Okay, it's very important. Only use that calculator.
यहाँ पे जो MS प्लस ये सिखा देंगे सर थोड़ा कैलकुलेटर में.
Pardon? अच्छा हाँ, M plus M minus वो सब.
ये सर ये वाला.
अच्छा, okay. So you are asking me to explain the use of it.
Yes sir. नहीं यूज तो क्या है मालूम है, कैसे यूज करते हैं.
हाँ, I mean it can save a lot of our time, but okay, let's discuss this after our 8 वाला class. कितने बजे class complete होता है? 8:45 के बाद. Remind me, so that in live class let's not discuss this. But yes, we'll discuss it. Okay. So calculations done, people. Any answer? Should I also check? So what do we have? 1 upon 15.78 the whole square. 1.5 into 10 raised to 11 ka cube is there, and 4 into 10 raised to 6 is there. So into 4 into 10 raised to 6. And this the whole raised to 1 by 3. This is equals to 1.5 into 10 raised to 11 upon radius. Okay. So let's do this. Calculator. So 1.5 into, so 15, not 1.5, this is 15.78. 15.78 square first of all. 15.78 into 15.78, that's 249 into 4 into 10 raised to 6. Got this? And raised to 1 by 3. Okay, so this value is 998, and R will be this into 1.5 into 10 raised to 11. Okay. So I'm getting approximately 1498 into 10 raised to 11. So that's approximately 1.5 into 10 raised to 14 I'm getting, people. So that's option D. Okay. Chalo. Have you understood the whole problem, people? The main reason I have taken this question in detail is to hammer this thing in your head that it's not always R cube. Okay. And capital M is not mass of the planet. It is mass of the thing which is at the center here. And another thing, in haste, do not substitute radius of the planet. R is radius of orbit of the planet. So take care of little things. Even though it's Kepler's, so it's very easy, it can get tricky. Okay? Chalo. There's a comment here. So I suppose I have an answer 24.0089 and have to specify that answer up to. Okay. See, don't worry about it, not critical, don't worry. But yes, since you are saying that this is your answer and they have mentioned that approximate to 3 decimals, it's better that you use approximation ka rules. So I will suggest you to write 24.009. However, I don't think they will be this rigid in the answer, because in IIT exam we have always given you range. So mostly they will give all the options from 24.008 to 24.009. All of them should be accepted in their paper. But for our safety, use approximation ka rules. 89 has to be written as 90 now, so you will write it 9. Use approximation rules. Okay? Just for safe side. Okay? Next. Chalo. So we were discussing central force. Now what next? So torque we discussed, central force का definition we discussed, and just a minute. I'm just going through
Go to
the.
the previous question once. I'll take the screenshot.
Pardon? अच्छा, okay. Question? हाँ. Okay. Next. So the formula for angular momentum. Something in the chat box here. So please discuss PYQ. It's a previous year question. I mean, see, Rita, I would have loved to do so many things, but the thing is, we don't have that much amount of time. Only if we had enough amount of time, I would have loved to do this and that and this and that. But okay, we are doing things as per the way the things are going right now. But okay, so angular momentum, people, it is mu r square theta dot. Okay, and I think force is mu r theta dot square. Circular motion, in circular motion, force becomes this, if you remember, because there you had mass into acceleration. Mass is mu, acceleration is r omega square. Omega is theta dot actually, omega is theta dot. So just ensure that you never get confused in these two formulas. And if you get confused, take a minute, take a moment, remember mass into acceleration. Mass is mu, acceleration, everybody remembers it's r omega square, no? And omega is theta dot. So that way you can always verify that which one was which formula, if at all you ever get confused. Okay? Then aerial velocity dA by dt, that was half mu r square theta, no, just half r square theta dot, correct? And this was also eventually L upon 2 mu. These are the things that we learned and derived also in the class. Okay. Then also, if I ask you what is the central force acceleration, which formula are you supposed to use? Take your time, think about it. Central force acceleration.
F is equal to minus d by dr. ये तो नहीं.
Tell me one thing, in central force, which kind of coordinate systems do we use?
Polar.
2D polar, to be more precise. In 2D polar, how many components of acceleration do we have?
2 component.
2 components. Which component is important when it comes to central force?
R
R
cap.
Radial.
That's it, na? So which acceleration you are supposed to calculate?
radial.
Radial.
So central force acceleration means radial acceleration. Okay? It's just another way to ask it. So that is basically r double dot minus r theta dot square. Make note. This is a central force acceleration. I just read one of these questions somewhere and I was like, okay, wow, interesting. Students would start scratching their head. What is central force acceleration? Okay. Okay. Then, force is obviously minus del u. That's fine. That we know. In this, another thing, because it's a 2D polar world, people, you have to use gradient ka formula for polar coordinates. So this is actually minus of 1 upon r dou u by, sorry, no. It is just minus dou u by dou r of r cap and
Plus 1 by r.
this has hung up. Arey yaar. Okay. Am I going to allowed to go to the next page? Okay, but I'll go to the next page. My screen is hung up on the right side. I hope it doesn't affect the class. Okay. So F is minus del u, which is minus of dou u by dou r, which into r cap, and there is a theta cap component also actually, which is 1 upon r dou u by dou theta. Take care of that. There is a theta cap component too, because we are in 2D polar world. However, the thing is, because in central force, this is only r cap term. No? It means this term becomes 0, people, always. This term will always become 0. Know? So 1 upon r dou u by dou theta, this becomes 0. Okay, it means u is not a function of theta, people. U is not a function of theta because partial derivative of u with respect to theta is 0. U is independent of theta. Make a note. Another good MSQ point this should be actually, that in central force, potential energy is not a function of angle or whatever we call it, pole attitude, anything.
The central force is a conservative value.
Yes, absolutely, absolutely. It is always conservative. Yes. Okay. Only then potential energy can exist. Now, remember, potential energy exists only for conservative forces. So, central force potential energy exists. No, it has to be conservative. Okay. Next. And then after this comes the most important in the heart of the chapter, that is the energy equation, people. In which, you know, we learned it in a way which I'm sure no other students of your age would have learned. That is the difference between the old conventions and the new
Old
conventions.
convention, new convention.
Yes.
Right, so.
Okay. So energy, which is given by two things. Either you say kinetic energy plus potential energy. In the old conventions, you have effective potential energy, and in the new convention, the total energy is given by kinetic energy, where you have total kinetic energy. And my right side is okay. Wait, so I will have to just shift this a bit on this side. Okay. So this is kinetic energy. Now we have total kinetic energy plus potential energy. There is only one potential energy this time. So when it comes to kinetic energy, in the old books, we had only one kinetic, and that was actually radial kinetic. But when it comes to effective potential, we had two potential. One was our centrifugal force potential energy, centrifugal potential energy, people, VCFF. Okay. And then there was central force potential, VR. This is central force potential. Okay. And this was centrifugal force, which is also known as pseudo force potential energy. Okay. Then we learned eventually that no, potential energy cannot be associated to centrifugal force because it's not a conservative force and it must be an interactive force. Potential energy always is associated to those kind of forces which exist, which interacts, okay, which should be real also. But anyway, then this was half mu. Okay, what is the formula here? Half mv square.
half mu r
Or
square.
the dot,
R dot square.
R square theta dot square. No,
No sir,
sir.
r dot square.
Achha, just R dot square. हाँ, right. VR square. Half mu R dot square plus VCFF, which is L square upon 2 mu R square. Correct? And V of R, you will write it V of R. Huh? Remember, V of R is not always minus K by R or K by R. It is only minus K by R or K by R for inverse square law forces. Write it. V of R will be plus or minus K by R only for inverse square law forces. Only for inverse square law forces. Otherwise, it's not plus or minus K by R. Otherwise, they will give you in the equation like R square, R cube, sin R, whatever. Okay. Otherwise, you will not write it. So V of R, we are going to keep it as it is. And now the new convention is where you write kinetic energy total, which is given by radial kinetic plus transverse kinetic. And there is only one kind of potential energy that should exist, and that is the central force potential. So this is half mu R dot square. This one is half mu R square theta dot square, and plus you have V of R. The thing is that this term and this term are actually one and the same thing. So centrifugal force potential is equal to transverse kinetic energy, and they both are given by L square upon 2 mu R square. Okay. And related to this, you will have many questions. Next. After this, so if we talk about only inverse square law forces, I hope you have copied things up. If we talk about only inverse square law, okay, now this is not even going up. Just a minute. Okay, good. So if we talk about only inverse square law forces, then what is it that we end up having? We have an equation, people, equation of orbit. equation of orbit, and that is for center, but inverse square of forces, sir. Equation of orbit, an equation which gives us information about any kind of motion.
L by R 1 plus E cos theta.
Yes, L by R is 1 plus E cos theta. So that's your basically equation of conic section only, because this equation tells us hyperbolic path, parabolic path, circular path, elliptical path, everything. But in this you have to remember the definition of each and every term. L, latus rectum, that is, I roughly remember, but still, minus L square upon, I'm not sure, I will have to check, mu k square, no? I think so. Yes, minus L square
Minus
upon
L square, mu k square. Yes.
And E, eccentricity, I think you will remember, that is 1 plus
1 plus 2 E L square by mu t square.
by mu k square, no?
K square होगा.
Mu k
K
square.
square. Okay.
By mu k square. Then it's fine. Okay. So after this, the conditions of all the four orbits. Any questions, people, so far? And L is not latest sectum, and L is semi-latest sectum. Just like semi-major axis, semi-minor axis. Please remember, M is semi-latest sectum. This is important because what if there is an MSQ and they're asking you the value of latest recturnus, and you end up calculating this, and it is there in the option, and you mark that. That would be wrong. They are asking you latest rectum, that would be 2L actually. Write it, please. This is semi-latest rectum actually, not latest rectum. And what is this K? K is this same thing that you have here. For example, the value of K. What is the value of K for gravitational force?
GM1 M2.
That's it. GM1 M2, GMM. Okay, because potential for gravitational force, people, is GMM upon R now. So value of K, this you can compare with K by R. Value of K for gravitation is GMM. Right, GM1 M2. And similarly for electrostatic, that will be 1 upon 4 pi epsilon naught Q1 Q2. That will be the value of K for electrostatic. Okay, next. Proceeding ahead. So about the conditions. So let's recall to start with. If our V effective, it was V effective only. Let me just recall a few things, one thing at a time. No, not V effective. If V of R is positive, then, okay, wait, people, in the total energy equation that we have, which is given by half mu R dot square plus L square upon 2 mu R square plus V of R. Understand that this is always positive. Why? Mass is positive and you have a square term. This is also positive. This is also always positive. This is also always positive because L is square, R is squared, mass is also always positive. So only guy who could be positive or negative is the central force potential, people. Only this could be positive or negative. So this is the thing that will be the deciding factor. The only thing that will decide the path of the, or a path of the comet, path of the planet, path of the asteroid, path of anything. The only thing that can decide the path is the value of the potential energy, people, of that particular object. Okay. So the first case was if V of R becomes positive, all of them will be positive. So energy will be greater than 0. And if energy becomes greater than 0, then eccentricity becomes greater than 1. Because 1 plus, this is greater than 0, you have 1 plus something. If eccentricity is greater than 1, it will be greater than 1, then the motion we get is hyperbolic. Any question, anyone? Please tell me if you have any questions. Okay? But when V of R is negative, now we have got many cases in this. 1, 2, 3, 4 cases. The first case is, this is negative, but still total energy is positive. That can happen, no? If this is negative, total energy can still be positive. Why? Because the magnitude of this whole will be greater than the magnitude of this. It's like this is minus 20 and this is, let's say, plus 50. Then total energy is still positive. So if that happens, even if V is negative, but energy is still positive, then eccentricity will be still greater than 1, then you will still get hyperbolic path. A good MSQ can be created on this, remember that. And MCQ too, in fact. Okay. Next, similarly, if energy would be, the next thing is if V of R is negative, such that energy becomes zero now. Such that energy becomes zero. So what happens to eccentricity? It becomes 1. And when eccentricity becomes 1, the path becomes parabolic. And one case is when energy is negative, so eccentricity becomes less than 1, and when it becomes less than 1, it becomes elliptical. And a very special case is when this energy reaches its minimum possible value. Energy reaches its minimum possible value. Okay, that is when eccentricity becomes 0 and you get a circular motion case. Clear, everyone? Let me keep this on silent mode. Chalo, done. Next. So this energy can be written as actually, like we know, radial kinetic plus effective potential energy. Now, the thing is, for apsidal distances, what is an apsidal distance, people?
Well,
And radial is kinetic energy becomes 0.
Yes. So basically, apsidal distances are perigee or apogee, the farthest or the nearest distance, perigee or apogee. Okay. In the first case, hyperbolic case, and in the parabolic case, apogee doesn't exist. Farthest distance is basically infinity there, because it's parabolic or hyperbolic. All that can exist is only perigee. They have only perigee. Okay. So in their case, what happens is the total energy becomes equal to V effective, or you can say the radial kinetic energy becomes 0. That's fine. Okay. Then in the third case, which is ellipse, you have both perigee and apogee. Both perigee and apogee. Again, the condition is total energy becomes equals to V effective, the radial kinetic energy becomes 0. Because if these two will be equal, radial kinetic would be simply 0. Okay? And in the fourth case, the only difference is that in the circle case, that energy and V effective will be equal. That's okay. Just that V effective reaches its minimum value, people. In that graph, if you remember, in that graph, okay, this was a hyperbolic case, this was the parabolic case, this was the elliptical case, but here all of a sudden you get your energy reaches its minimum value. It reaches its minimum possible value, and that is the circular motion case. So this is where you get radius. You get radius. All the points are perigee, all the points are apogee. Basically, all the points are equidistant from the center this time. You get radius. Okay. Radial kinetic energy will still be 0. Radial kinetic energy will still be 0. The only additional condition in case of circular motion is that since V effective minimum is 0, you can first write radius exists. It means all the points are perigee, all of them are apogee, all of them are equidistant. And how do we find that radius? For minima, there is a condition for minima, right? That is derivative of V effective with respect to R, that will be 0, people. Using this, you can find radius. Any questions? Anyone?
Sir, turning point क्या है sir? ये perigee and apogee है ना?
Wait, that is the turning point only, because from there you are going to reverse the path. Yes, absolutely. Nice. I mean, it's a good way to ask the question, but it should be understood. Turning point, it has to be perigee. Okay. Then people, do you have any questions?
Yes, sir.
Anyone? Okay. Let's recall the graph for a while. So this was our graph of V effective versus R. Total energy is always constant. For hyperbola, total energy is here. This is for hyperbola. It's positive, no? Simple. Okay. For parabola, it's here. This is total energy for parabola. Okay. As you see, people, this is where, I repeat, listen to this. This is the point where V effective and energy are intersecting with each other. So this is the distance. This is your apogee. Understood? Sorry, this is the perigee for hyperbola. It's like suppose this is your sun and you get that comet. Comet is traveling. It reaches a point and then it again goes. Okay. So this is that R apogee. R apogee. Sorry, not apogee. Perigee. R perigee. Where V effective and energy intersects with each other. Any questions? Okay. For parabola, energy is here. So this is the RP for parabola, people. This is the perigee for parabola. So you will have sun and this will be the parabolic path and this will be your perigee. Actually, it's a good question. No? Somebody can ask, somebody should ask, like the perigee distance of parabola is greater than hyperbola, less than hyperbola, equal to hyperbola, or what is it? It becomes a very good question now. And as we can clearly see, the perigee distance of parabola is greater than the perigee distance of hyperbola. Hai na? This,
Yes.
are you understanding what I'm trying to say, people here? This is the graph
Yes,
of
sir.
V effective. Okay. And here energy is here for parabola. It's zero. Na? Energy is zero for parabola. For hyperbola, it's positive. For parabola, it's zero. So this is where they are intersecting. So this is the perigee distance for parabola and this is the perigee distance for hyperbola, people. Clear? Okay. And then we have got ellipse. For ellipse, energy becomes negative. For ellipse, energy becomes negative, and we have got 2 points, point 1 and point 2, R1 and R2. This becomes perigee, this becomes apogee for ellipse. And for circle, energy becomes minimum. It reaches V effective minimum. It reaches V effective minimum here. That's it. And you get circular motion. Okay. This is your R naught, R circle. Should we proceed?
सर पेरिजी डिस्टेंस सबसे ज्यादा सर्कुलर पाथ की हुई है.
Yes, absolutely. It's a good way to say. So perigee distance for circle is greater than the perigee distance for ellipse, is greater than the perigee distance for parabola, is greater than the perigee distance for hyperbola. Absolutely. Okay. Basically for circle, all the points are equidistant, but yes, you can call it perigee. But a good way to ask. I mean, it should be asked in one of the paper, you know. Nice. Okay, chalo. The next, proceeding ahead. Let's take questions now in a theory. Wait, which was the last question number that we did yesterday? I think 14. So 15th, yes, 15th. Let's take question 15. Here we go. So a particle of mass 15 grams moves under an attractive central force of magnitude 4r cube times. So central force is given to us 4r cube. It's attractive, so there is a minus sign. First thing. Okay. Next, a particle of mass, and they are asking us its effective potential energy is. Okay, now it's a time pass question. What is effective potential energy? It is given by L square upon 2 mu r square plus V of r. So we want to find V of r first of all. How do we find V of r? It's minus integration of f of r dr. है ना? Reference position to r. The reference position, I hope you remember, we decide, we choose. So this is minus integration f of r, which is minus 4r cube dr. You go from reference position to r. Minus minus plus 4. Integration of r is to 4. That's r is to 4 by 4. The reference position to r. What should be the reference position now, people?
0.
0. Because only if r is 0, br is 0. Reference position is that position where potential energy becomes 0. So that you have to choose. So now we will choose reference position as 0 because only if r will be 0, b of r will be 0, upper minus lower. So r raised to 4 minus 0 raised to 4, which is r raised to 4. Okay. So V effective we have found out it's L square upon 2 mu r square plus r raised to 4. And I think now we have to just substitute the values and done. Okay. See, everything is in erg here. It means we just need CGS values. So our answer would be r raised to 4 plus L square. L is given to us 1000. So keep it in CGS. Huh? Keep it in CGS. Upon 2 mu. Mu will be m. Mu will be small m only. Reduced mass is actually always equal to the smaller mass, which is the mass which is orbiting around the central mass P. Always. Okay. I hope you remember this. Reduced mass is always equal to the
Yes, sir.
smaller mass. Okay, it's like mass of electron, which is revolving around nucleus, or mass of Earth, which is revolving around Sun. It is always equals to the smaller mass if it is revolving around a very large mass. Okay, so it will be equals to 50 gram only. So L square upon 2 mu R square. So our answer would be R is to 4 plus 10 is to 6 upon 100 R square. So 10 is to 4 upon R square. Answer is option. Nice question. Done, shall we? Chalo, next. Let's take another question. Question 16. Okay, a particle of mass moves under a central force Kr is to 4 with angular momentum L. The distance R naught at which the effective potential becomes minimum. I think this one you can do. We know what we are supposed to do with this. So V effective is given by L square upon 2 mu R square plus V of R. They have given you central force this time. Huh? Take care of that. And again, attractive central force is given to you. So just like last time, F is given, you can calculate V of R. And once you calculate V of R, what are you supposed to do?
डेरिवेटिव निकाल के जीरो कर देंगे.
हाँ, but
डेरिवेटिव
you just-
कर देंगे, जीरो कर देंगे.
Yes, you will substitute it here. They are asking you the distance R naught at which effective potential becomes minimum. So do this later. Chalo, copy this. Just take a screenshot. Okay, next.
So, sir, previous question में
हाँ, sure.
thank you, sir.
Okay, substitute it here and then you will just differentiate it with respect to R, equate it with 0 and find the value of RB. Next, 17. So this one, a particle of mass m moves under an attractive central force Kr is to 4 if the motion is circular with R naught, find the Achha, haan, actually that's what I was thinking. Why did I take this such a chindi question in the class? No, actually we need to solve this because a result that we are going to establish in this that I'm supposed to use in this. Okay. So, okay, let's just quickly solve this one, okay? Because we'll need a result. Or have you taken a similar question in the class? You know? No? Okay, leave it. Chalo, let's discuss this. Okay.
Are you going to discuss about how to get this simple harmonic oscillations?
That's what, yes.
Yeah, you have given us the concept.
Correct. But let's take a question on this, maybe. I'm not sure. So,
Yeah, okay.
okay. I mean, it's up to you guys also. I think we should take a question on this. So let's just take this.
Yes,
Okay,
sir,
so
please.
So we have got to start with V effective. Let's quickly calculate. First, let's calculate V of R. So that's minus of F of R dr from reference position to R. So this is minus of F of R attractive central force. Take care. So this is minus Kr is to 4. Why do I feel that maybe there is a, okay, let's just check. Maybe this should be potential only, but okay. Okay, Kr is to 4 dr, reference positions to R. Because we, how will we eliminate phi? I think a term potential is missing from this. That's what I feel. But okay, we can just quickly check. Kr is to phi by, because we are getting Kr is to phi by phi, then we will differentiate things. Achha, haan, okay, no, it's fine. We will be differentiating it now. We'll get 5r is to 4 again. Okay. So Kr is to phi by phi. This goes from reference to R. And again, we will choose reference position as 0. So upper minus lower. This is just Kr is to phi by phi. This is V of R. So our V effective people. Let's first calculate V effective, which is L square upon 2 mu R square plus V of R. So this is given by L square upon 2 mu R square. Mu is M. Okay, mu is M. So L square upon 2m R square plus V of R, which is Kr is to 5 by 5. Now let's calculate separately derivative of V effective with respect to R. Don't equate it with 0 immediately. This I'm doing it for the next question. Okay. These are the steps you are supposed to follow to find the frequency kind of questions, like this question that we want to do, find the frequency of radial oscillations. For these kind of questions, the steps we are following is the ones that we are doing right now. Okay. So the first step is find V of R. Second step is find V effective. Third step is find derivative separately. Don't equate it with 0 immediately. Okay. So this would be L square upon 2m. What is derivative of 1 upon R square? That's minus 2 upon R cube plus K upon 5. What is derivative of R raised to 5? That's 5R raised to 4. So 2 gets cancelled. We have got minus L square upon mr cube plus kr raised to 4. Copy this much fatafat.
Yes, sir.
Okay. And now this equation we have to equate it with 0 because they have mentioned that the effective potential becomes minimum, people. Acha, in which condition effective potential becomes minimum? We learned the rest of this.
At mean position for oscillation.
No, in respect to with respect to central force.
At R equal to R
At
naught.
apsidal distance. Apsidal
Basically,
distance.
for circular motion.
Yes, sir.
No,
मैंने बोला
not for apsidal distance.
Okay.
Not remember. V effective is not minimum for all the apsidal distances. Huh? For all the apsidal distances, radial kinetic is 0, but V effective is not minimum. V effective was higher value. It was higher value. It was equals to total energy. It is equals to total energy. Okay, this needs to be cleared up. Have a look. For hyperbola, V effective is this, people. It's not minimum. For parabola, it's not minimum. For ellipse, it's not minimum. Only for circle, V effective becomes minimum. But for all the other cases at apsidal distances, radial kinetic becomes 0. V effective becomes equals to total. That does not mean it is minimum. V effective is still a large value. Write it clearly that V effective is minimum only for circular motion case, not for any apsidal distance case. Now, write it. V effective is minimum only for circular motion case. Write it, please. V effective is minimum only for circular motion case, not for all the apsidal distance case. Now, for all the apsidal distance, what happens is V effective and energy becomes equal and radial kinetic becomes 0. This is valid for all the apsidal distances, for all the cases. Okay. So when you say here that it's an attractive, okay, potential becomes minimum. So this is a circular motion case. The path, the orbit, it must be circular because they have mentioned V effective has reached its minimum value. So it has to be a circular motion case. Okay. So now what we can do is, let me remove this just a second. So let's, the fourth step. Third step, like I told you, it's finding dVf by dr. Fourth step is, this will become, listen, this will become 0 only for circular, not for anybody else. Only for circular. Basically, V effective becomes minimum only for circular. Otherwise, this cannot happen. Okay? So it happens at R equals to R naught. And this is radius, not any apsidal distance. This is radius. Okay? So we have got minus L square upon 2 mu R naught square. Now, sorry, not 2 mu. It is just minus L square upon mr square. Now we got this. Minus L square upon mr square. Not 2. There is not 2 here. So minus L square upon mr square. And then you have plus kr raised to 4. Plus kr raised to 4. This is 0.
MR क्यों होगा सर?
Yes, sir.
It's cube actually. I have written square here, but this is cube. Absolutely, yes. Thank you. But we will make it R naught immediately. And now this equation you have to note. This is the one that we are supposed to use for the next question actually. Okay. So by the way, this problem is now done. So you can actually calculate R naught from here. So what do we get? We will get my kr naught raised to 4. This is equals to L square upon m R naught cube. So we are going to get R naught raised to 7. This is L square upon k, mk. So R naught is L upon m, L square upon mk, the whole raised to 1 by 7. So that answer is option C. That's good. Let's see, Maybe this question we could have done using dimensions also, don't you think? but बहुत मेहनत लगता, but we could have done it because all the options have different dimensions. But yes, a lot of efforts would be needed to find dimensions of each physical quantity here. Okay, but anyway, done. So let's take the next one. And this equation, people, you are supposed to use for that frequency type of questions. So basically, listen, a popular question is where they will give you an object at the center. They will give you another object which is revolving in the circle. Potential will be given to you just like in this question, which is given by r is to 5 or kr is to 4 or whatever, some potential will be given. Because it is in circular motion, now they will give you a small radial impulse is given to the guy which is moving in circular motion. A small radial impulse is given, but there is an attractive force now. So attraction, like it is going to pull it back. So the point is when it will go forward, it is also going to come back, and they're asking you the frequency of. They're saying that because it was also moving in this circular motion, because now there is also pulling back, but there is also forward motion. So now it will kind of conduct a spiral motion, something like this. Let's say this is M. Let's say this is the object. It was initially moving in circular motion. Remember, there is a forward velocity all the time. There is always a forward velocity, and there was a small radial impulse given. So when it will try to go in this direction, attraction is going to pull it back. So it is going to come back, and due to inertia, it will continue its motion, people. So now it's like it's kind of going to perform a spiral motion. So they are asking you find what is the frequency of oscillation or whatever. Okay, that's what we need to find here. But okay, let me just now take that question. Where is it? Question 17 actually. So after this, first we will talk about V effective. What is V effective? L square upon 2 mu r square plus V of r, and V of r we have found out L square upon 2 mu r square plus V of r, which is given by kr raised to 5 by 5. Okay. We need to find value of this V effective at so what is value of V effective initially R naught, when it was initially in the circular motion, when the motion was circular V. Okay, it will be L square upon 2 mu R naught square plus K R naught raised to 5 by 5. And now you have given it small radial impulse. Okay, a small radial. So small displacement is given. So what will happen? Initially the distance is R naught. Now the distance will become R naught plus X. A small addition. Okay, R naught plus X. So what do we have? V effective R naught. This becomes equal to L square upon, sorry, V effective R naught plus X. This becomes L square upon 2 mu into R naught plus X the whole square. Understood? Plus K into R naught raised to 5. K into R naught plus X the whole raised to 5 by 5. This is the value of potential energy after you have given it small displacement. Any questions, anyone? All good?
Yes, sir.
Yes, sir.
Now, so since this is the potential energy, what is force, people? Force will be minus dVef by dr. Okay, so this will be minus d by dr of what is Vef now? It is given by this whole formula, which is L square upon 2 mu into R naught plus X the whole raised to 5 plus K R naught plus X the whole raised to 5. No, there is not 5 here. There is square here. There is square here plus K R naught plus X the whole raised to 5 the whole upon 5. Copy this much. Ask me if you have any questions. Since there is a change in effective potential energy, there will be now a force. The force which has led to this change. Now, there is a force which has led to this change. So we are trying to find that force.
Yes, sir.
Okay. Okay. But after this, it's purely mathematics. What we are supposed to do is, what is the question? Read it. It's the same question. Just read the end line. If the motion is circular, okay, forget that. Find the frequency of radial oscillations if the particle is given small radial impulse. People, for oscillations, okay, The rule is f must be minus of kx. You know that. Okay. So all we have to do is we have to solve this derivative and we have to get minus of something into x. That something will be k. And once you get the value of k, how do you find frequency?
is equal
1 by
to
2 pi k by m.
Yes, 1 upon 2 pi under root of k by m. That's it. Okay? So we have to solve this. Let's do that quickly. So we have minus of L square upon 2 mu into 1 upon r naught plus x the whole square, which will be given by minus 2 upon r naught plus x the whole cube. That's the derivative now. Derivative of 1 upon n into x raised to n minus 1. Yes, this is correct. Okay. And then plus k by 5 into r naught plus x the whole raised to 4. Correct? I hope I'm going in the correct direction.
5 cancel हो जाएगा ना सर?
हाँ 5 cancel हो जाएगा. And here also 2 will get cancelled. So we have got L square upon mu, okay, into r naught plus x the whole raised to minus 3 plus k into r naught plus x the whole raised to 4. What should we do after this?
Binomial.
Very good.
Double
That's what-
expansion.
Yes, because they have mentioned that x is very small. So all we will do is we'll take r naught common people. Okay. So let's take r naught common. This becomes r naught raised to minus 3. Then we have 1 plus x upon r naught the whole raised to minus 3. Similarly, let's take r naught common, r naught raised to 4. So we are left with 1 plus x upon r naught the whole raised to 4. Any questions, anyone? All good?
Yes, sir.
Others, take your time.
Yes, sir.
Take care. So first, now we have got L square upon mu into r naught raised to minus 3, which we can write 1 upon r naught cube, whatever. What do we have? 1 minus 3x upon r naught. You know, what is the formula of binomial expansion, people? 1 plus x the whole raised to n. This is 1 plus nx. So 1 plus x upon r naught the whole raised to minus 3. This is 1 minus 3x upon r naught. Okay. Similarly, plus k r naught raised to 4. We have got 1 plus 4x upon r naught. Okay. And now if you will open the brackets, what you are going to get, that is the fascinating part, people. See, open the brackets. So what do we have? We have got L square upon mu r naught cube, L square upon mu r naught cube minus 3x upon r naught raised to 4 minus 3x upon r naught raised to 4. No, sorry. Minus, what is it? L square upon mu, L square upon mu into 3x upon r naught raised to 4. Okay. And then we have k r naught raised to 4. And we have k r naught raised to 4, 4x upon r naught. K r naught raised to 4, 4x upon r naught. Okay. People, what is this guy? Okay. This and this. L square upon mu r naught cube plus k r naught raised to 4. Here. Equation 1. What is equation 1? Where is it? There is a minus sign here. Have you missed out on a minus sign somewhere? Minus of derivative of E effective now. Minus is applied to both the terms. Minus is applied to both the terms. So this also becomes minus. This also becomes minus. This becomes minus. I hope I'm going correct. Okay. So this also becomes minus. Then, so this is minus and this is also minus. Okay. So people have a look. L square upon m r naught cube, this is k r naught raised to 4. That's the condition. Equation number 1. L square upon m r naught cube, it is k r naught raised to 4. Equation 1. So these two get cancelled, people. L square upon m r naught cube is k r naught raised to 4. That is the reason I said that I wanted to take that question. That's a part of this question, basically. Okay. And now we have got the terms. So what do we have? Take x common. See, you have got minus. We have got L square. We have got minus 3L square. Minus of 3L square upon mu r naught raised to 4. And then we have got plus 4k r naught cube. Okay. Into x. That's the answer. है ना? Minus L square upon mu r naught raised to 4, 3. And I've taken x common. Just look, I've taken x common. I've taken minus common. Here also, I've taken x common and I've taken minus common. R naught gets cancelled and you are left with cube. So this is minus of kx. This is the value of k, people. This is the value of your spring constant, force constant. And now you can find frequency, which is 1 upon 2 pi under root of k pi m. Any questions, anyone? Please ask. What are you thinking?
Just processing it.
Just processing it. Maybe I am not sure if I should have taken this question in the class or not. Now I'm thinking because it has become too heavy. Okay. Others, any questions do you have at any step? Okay. So that's it. Now you have to find the value of k and substitute, and we will get the result that people. There could be a couple of tricks in this. Like for example, I'm thinking. Just a second now. See, this relationship you can use. K r naught raised to 4 is L square upon m r naught cube now. So this relationship we can use. Here, the value of k that you have, you can substitute, you can replace L square actually. What is L square? Here, what is L square? Where is it? L square is k r naught raised to 4 into m into r naught cube now. So it is mk r naught raised to 7. Substitute L square, people. Mk r naught raised to 7. Substitute that now. Mk r naught raised to 7. So this is minus of 3 upon m r naught raised to 4. And what is L square? I forgot. What is L square?
MK R naught power
Mk
7.
r naught raised to 7. And then you have 4k r naught cube into x. So what do you see? Gets cancelled. R naught raised to 4 cube. You are getting 3k r naught cube, 4k r naught cube. So the total is minus 7k r naught cube x. So what is the value of capital K, the spring constant or the force constant? It's 7k r naught cube, people. So your answer is option D. 1 upon 2 pi under root k by m. ठीक है? Are you alive?
Yes, sir.
Yes, sir.
Okay. See, central force is a heavy topic, but ठीक है. Let's see, hope we get some good, nice questions. Next, 18. This is not a heavy question, but okay, wait, let me just see if there is something else. Let's discuss a few chillax questions after which you feel good, and then maybe we can take that. Okay, so what about this? Not a difficult question, but just something that I want to discuss. 3 particles, each of mass m, are placed at the corners of an equilateral triangle of side D. The potential energy of the system is. How do you find potential energy of such system? There is a
Scalar
sign.
addition of each potential by pairwise.
Pairwise, okay. ठीक है. So I mean, maybe you'll have to try and solve and maybe tell me, but okay. So we have got 3 particles, M, M, and M. All of them are at the sides of this equilateral triangle of side D. they're asking you to find potential energy. People, potential energy is basically work done to bring all the charges, all the masses, work done, total work done. So when you will bring the first mass, do you have to do any work? No,
Zero.
because nobody
No.
was present. So work done to bring the first mass is actually 0. But when you will bring the second mass, suppose this was the first mass, let's say this is the second mass. When you will bring the second mass, you have to do some work now. And what is the work? Minus gmm upon d. Correct? The work done to bring the second mass is minus gmm upon d. Because one mass is already present. Are you with me until here? Please tell me if not. When you brought the first mass, there was no work done. Now you brought the second mass. To bring the second mass, you did a work. The work formula is nothing but minus gmm upon r. R is the distance between them. And that is basically d right now. So this is minus gmm upon d. And now you will bring the third mass. But when you will bring the third mass, okay, now first mass is also present. Second mass is also present. So there are two masses. Minus gmm upon d because of the first mass. Minus gmm upon d because of the second mass. So your answer is minus 3 gmm upon d. Okay, that's it. Not a difficult question, like I said. Minus 3 gmm upon d. But I wanted to discuss this to remind you that if there are multiple masses, how do you simply calculate? Bring the first, you don't have to do any work. Then you will bring the second. Work is done with respect to the first. Then you will bring the third. Work is done with respect to the first and second. Then you will bring the fourth. Work will be done with respect to the first, second, third. Okay, that's it. Next. Proceeding ahead. Sorry, 20. This one I have taken only and only to remind you the shortcut formula that in fact taken in the class. So if the radius of the earth were to
एंगुलर मोमेंटम कमजोर करके निकाल सकते हैं
कौन सा क्वेश्चन
ये
अच्छा okay, so angular momentum concept. Okay, wait, if the radius of the earth were to shrink by 1%, its mass remaining the same, the value of g on the earth's surface would be it's not required. I'm not sure why angular momentum you're planning to use. Directly you have the formula for g now. G is gm upon r square. Mass remaining same, okay, radius is shrinking, capital G is always constant, mass they have mentioned is constant, so G is inversely proportional to R square.
So it decreases by 2%.
Yes. Okay, your answer. Yes, absolutely correct. So G is proportional to R is to minus 2. Shortcut formula, that's what, this is the reason that I have taken this to remind you that whenever the percent is 1%, 2%, 0.5%, 3%, 5%, anything less than 10%, then you have to use this direct formula. X raised to n is proportional to y raised to m. Then n delta x upon x is equals to m delta y upon y. So this is g raised to 1 proportional to r raised to minus 2. So 1 delta g upon g. This is minus of 2 delta r upon r. They have mentioned that radius. Okay, I think. Arun, you said decreases, not decreases, increases. Be very careful because they have mentioned radius shrinks by 1%, decreases by 1%.
Okay.
Okay,
Yes,
so it decreases by 1%. So it's minus 1%. Minus becomes plus 3. So answer is it increases by plus 2. Increases by plus 2. Option B. People, when you say shrinks by 1%, it means the radius decreases by 1%. So it's minus 1%. And minus will become plus. So gravity will increase by plus. Okay. So I'm glad I did this question because if something like this is asked in the exam, you will remember to just check about the plus minus convention first. Any questions, anyone? Please ask. ठीक है?
Yes, sir.
चलो next 21. This one we already discussed, and 22, that is related to rolling motion now, so that we don't have time. Okay, let's discuss this one now then. Okay, so a small asteroid is approaching a massive star with a speed v from a very large distance at an impact parameter b as shown below. If the mass of the star is capital M and its radius is capital R, what is the minimum value of B such that the asteroid will miss the star? Okay. Sorry, you have to ignore this. Okay. First of all, a small asteroid is approaching a very massive star with a speed b from a very large distance. People in physics, whenever they tell you a long wire, what is the meaning of it? You take it infinite. When you say a very large distance, you will take it infinite. Okay? You know this, right? Whenever you take long wire, you take the infinite wire condition. Then you take, for example, if I ask you to find electric field of a long wire, it means they're asking you to consider infinite wire, which is lambda upon 2 pi epsilon naught r, then you will end up using. So the point is, long is related to infinity for us. So when they say it's at a very large distance, it means the distance was practically infinite. So at infinite distance, potential energy would be zero initially, don't you think? Okay, it's a gravitation question. Okay, so potential energy will be zero, but it was approaching a massive star with a speed v. So the speed of the star initially was v. So there is a kinetic energy, people, which is half mv square. So what will be total energy, people? Potential plus kinetic. So this will be 0 plus half mv square, which is half mv square. So total energy is half mv square. This should remain constant always. Now listen. They are asking us if the mass of the star is capital M, this is it. What is the minimum value of B such that the asteroid will miss the star? So they are talking about distance of closest approach, people. Okay, it means you know what is going to happen. It will come like this, and then it is going to either repel up, either it will go away if at all the K is positive, or it will come like this and it will go like this. Either of two is going to happen. In gravitation, this happens. Where does this happen, people?
Rutherford's
experiment. Yeah, this happens there. In gravitation, something like this is going to happen. So they're asking us to find the minimum possible value of B. Minimum possible value of B, after which it is going to such that the asteroid will miss the star. Okay, so
you have to get the potential energy becomes equal to kinetic energy. That would be enough, I believe. At that point,
no, it's not how. See, that is how a solute. Like if at all you have solved a similar question like this, so books write potential equals to kinetic, but the question is why potential and kinetic becomes equal. So that's what total energy is actually equals to half mv square. Now what happens at closest distance approach? At distance of closest approach. At distance of closest approach, basically our perigee, distance of closest approach, because it is just going to miss the star. No? It is just going to miss the star. So it has reached its maximum. Sorry, it has reached its closest possible distance to the star. Okay. So at distance of closest approach, what happens? We are at perigee. We are at perigee. And what happens at perigee?
Radial
kinetic becomes zero. So total energy is equals to only potential energy now. Okay. But what is total energy already? Total energy is half mv square. So this is the reason that in books half mv square they write it is equals to potential. But it's not because kinetic and potential exactly becomes equal. So total energy was initially half mv square because the star was approaching from infinity, and then at perigee, total energy becomes equals to potential energy. So it's like kinetic was converted to potential. It does not exactly become equal to potential. The complete kinetic energy was converted to potential energy. So half mv square was converted to P. Okay. Copy this. I'll have to check something meanwhile. Mhm. Done? Okay.
Yes, sir.
Yes, sir.
So half mv square, that has become equals to our effective potential energy. This is effective, na? Radial is 0. So when you say potential energy, this is our effective potential energy, V effective. Okay. So this is half mv square. What is effective potential energy? L square upon 2 mu r square plus, this is a gravitation problem. So what is V of r? That's minus half mv square. This is L square upon 2 mu r square. What is V of r? Minus gmm upon r, just r, minus gmm upon r. है ना? And okay, so I think this is it. Now we just have to solve this. So half small m v square. This is L square upon. What is the value of mu people? It becomes equals to small m. है ना? Because capital M is very large. This is asteroid, and this is star. So reduced mass becomes equals to mass of asteroid, which is small m v. Okay. Tell me if you have any questions here. So this is
Just a simple question.
पूछो.
I mean, if I would have done this problem, I would have just used the concept of gravitation. I mean, how can I differentiate whether I have to use V effective or just the V of gravitation? क्योंकि वहां तो सिर्फ ये लास्ट टर्म ही तो आएगी सामने
Last
L
time
स्क्वायर पर. I mean, अगर मैं होता तो मैं GM by M by R equate करता half MB square and I will have come back. I would have never thought about including L square by 2 mu R square. V effective.
No, that's the thing. Na? So this is where our limitation, like our knowledge of having a BSc degree comes into picture. So for example, I had also explained you guys in the class that we have learned always that potential energy is mgh. But now we have learned that it's not always mgh. Mgh is actually a condition which we use only if height is very small. It is close to the surface of the earth. And also it's not potential energy, it's actually the change in potential energy with respect to the surface of the earth. So like right now it has a potential energy on the surface. From the surface, what is the change? That is actually mgh. So that's what. So now in physics, in throughout our physics, we have to use, when it comes to total energy concept, we have to consider everything. We have to consider angular momentum. We have to consider radial kinetic energy. We have to consider everything. There is no escape.
Okay, so
It's a generalization, a simple. It's a generalization. So we have to consider it. Okay, but no problem. So unless and until L is becoming 0, so L won't become 0. So that's fine. Okay, half mv square is this, and now just substitute. We are done. They are asking us distance of closest approach. No? See,
how will you find L here? Just
that
trusting.
L is this R cross P. Okay. So see, let's say the particle reaches here, and then it misses, and then it goes like this, some hyperbolic or parabolic path or whatever. Okay. So let's say this is the closest approach distance. So perigee is nothing but B, people. Perigee is nothing but B itself, and they are asking you the minimum possible value of B. What will be angular momentum? Angular momentum is R cross P. But what is the magnitude? Can I directly write? Do you remember? It's P into R perpendicular, just like
Yes,
F
sir.
into R perpendicular. That's it. So MV into what is the perpendicular distance? B. MVB.
Okay, sir.
Clear, everyone? Please tell me if not.
Yes, sir.
Okay, angular momentum, just like torque is R cross F, and it is actually F into R perpendicular when it comes to magnitude. Here, magnitude will be P into R perpendicular. P is mass into velocity, and the perpendicular distance, this is velocity, no? So perpendicular distance of the velocity is actually B. See, perpendicular distance of the velocity is actually B. Okay? From the center here, origin. Or if you don't like that idea, you can also look at this way. This is R, okay? This is V, okay? The angle between them is theta. Here the distance is B. So when you write angular momentum, which is R cross P, okay? The magnitude is given by A cross B is AB sine theta. So this is RP sine theta. But then you have to find the value of R sine theta. So this is R. Calculate sine theta, no? It's B upon R. So R sine theta, this is B. This way also you will get the answer. R sine theta is B. So P into B, which is MVB. Or you could have directly written, like I said, R perpendicular into P people, which is R into MV or MVR. Take your time. ठीक है? Next. So what do we have? Half M V square. This is given by MVB the whole square upon 2M B square minus GMM upon B people. And we want to find the value of B. So I think we are done. We just have to adjust this. So half M V square. This is given by B square gets cancelled. And then we have got no, something is weird. Just a second. Okay, something is capital R here. Who is capital R? Which guy is capital R? L square upon 2 mu R square. This is V effective. Is the denominator capital R? No.
Small r capital R.
Small r is capital R. But why? Capital R is the radius of the earth, huh? No. Capital R is the radius. Then why capital R will be small r? I mean, for the sake of answer, we can write it. But why should capital R be smaller? Let me just check this. We're very close to the answer. Just one thing we need to confirm in this. I'm just looking at the solution. I have solution of this. So, they have also written asteroid will just. Acha, okay. They have written asteroid will just miss the star if the asteroid is very close to the. What is the meaning of just? It is very
B
close.
equal to R.
So small r will be equals to approximately equals to capital R. That is the meaning of just missing it. Okay, good. Then, so, okay, let's substitute. So we have got half mv square. This is L square upon 2m r square minus gmm upon r. Okay. So we have got half mv square plus gmm upon r. This is L square upon 2m r square. So we have got 2m r square into half mv square plus gmm upon r. This is L square. So that's it. L is given by under root of this. Take 2m inside and I think we are done. And then you have to write capital L is mvb and you get the value of bb. Copy. I will tell you the final answer. So the final answer is R into this one. Option A. Option A is the answer. Just take square root and manipulate. Answer is done. Okay, just take square root and manipulate. Capital L is this. Okay, capital L is this. Remember, capital L is MVB. So MVB is this term. So you will get B. You will get B, and that's the answer. Please copy. Tell me if you have a question here.
So actually we are trying to find that distance of closest approach, right?
Yes.
So why can't I take in that can you put half mv square equal to L square, the next slide, that final equation. वहां पर हम r की जगह b नहीं लिख सकते directly?
In that case, so r will be equal to b. They are asking you to find the value of b.
सर r equal to b भी हो सकता है.
हाँ, क्योंकि यहाँ से देखने पर तो
यस
just
सर, वही मैं
miss
सोच रही सर। आर इक्वल टू बी तो
PV
क्वेश्चन
हो
नहीं कह
सकता
रहा है।
है. It can also be a case. That's I was a little confused there.
Because when you say the find the value of b such that it will just miss. So it will just miss the star if the value of small r is capital R. So when you say small r is actually capital B only, no? Small r has to be
Yes,
capital
sir.
B. हाँ,
तो हम
because
वहाँ
this
पर
is
डायरेक्टली इक्वेट कर सकते हैं वहाँ पर.
हाँ,
उस
it should be
equation
capital
में.
B only. This is actually a question, you know, of IISc 2009 people. And the problem is I don't have the real answer key of this is not available. Okay, that's one of the major problem that we have. But it could be option C to mathematically you will end up getting A if you write small r as capital R. But what is the meaning of it then? Like for example, if we have this mass and if you have an asteroid which is coming, the value of small r is actually this. This is small r, the distance between them. And if they are asking you find the value of b such that v effective would be minimum. So v effective, no, sorry, find the value of b such that asteroid will just miss the star. So what is the meaning of just missing the star? It means that it has to be equals to r. Now b and r will be equal also. Okay, but ठीक I mean, at the end of the day, the concept is the concept that I wanted us to learn in this was this part where initially when they say that the particle is very far, you have to remember it means potential energy is zero, total energy is equals to kinetic energy. And when they talk about distance of closest approach, it means obviously you have reached perigee, so kinetic energy will become zero and total will become equals to effective potential. So that's the main concept. Apart from that, let's skip this part. Otherwise, mathematically we'll end up getting A, but it doesn't make sense to us. It has to be B and R, that has to be equal. That is the only meaning of it. Unless there is a different diagram altogether. Okay. Unless there is a different diagram altogether. So because in the solution that I have here in this book, they are literally writing asteroid will miss the star if small r is capital R. But when you say smaller is actually B only. Smaller and what is the difference between smaller and B? Because at the closest distance, smaller and B will become equal. At the closest distance.
And that makes sense
Capital R
also.
equal
Pardon? What did you say?
कैपिटल R इक्वल टू हुआ ना B.
Arey, nee, listen. Arey, this is outstanding. People tell me one thing. What will be the value of velocity at at perigee? See, no, again, this is actually in terms of this. Okay, no, this is good. Since you are writing this, what do you say?
आर होगी तो टकरा जाएगा.
I mean, but still, you are using the condition anyway. No? We have to use this condition that what is the minimum value of B such that asteroid will just miss the star. What is the meaning of just miss the star? It's just what is missing in my question. Just a minute. The time is anyway running out, but okay. Asteroid will just miss the star. Just is missing here. For it to just miss the star, small r is equals to capital R, that is fine. But when we say small r is capital R, it doesn't make sense. B and R, it has to be same. Something is hilariously wrong in the question. Leave it. Okay, just skip this part. We'll stop here.